Well, thank you for joining. This speed is Lex distributors' role for supply chain security. At first, let us introduce ourselves.
Hi, I'm Takanori Suzuki. I'm leader of Cybertrust Japan OSPO, and I'm Chief Open Source Officer. And currently, now I'm working for the growth of the Urban Linux community and development environment in Japan. And so I will talk about this kind of supply chain security thing from the aspect from the Linux distribution development and supplement.
Hi, I'm Muuhh Ikeda. I'm also working at Cybertrust Japan, and I'm always a lover and a believer through my life. And I'm working for him. He's a chief office officer, so I'm a royal servant of him. That's Japan nature. Okay, let's start. First, I'd like to share the big picture of ideal software supply chain security. Look at that. The supply chain security, supply chain is, of course, the chain from the development, coding, compiling, testing, packaging, and integration, and use, execution. It's a chain. And this is a supply chain, and what the supply chain security? Supply chain security is, in short, in my opinion, that we can verify what the software is, what is inside, what component is included in the software, and what process was applied by whom. Yes, that's and which route the software was going through. So everything is accepted, and if we can verify that, that supply chain security is kept. So to do so, of course, we have to output some metadata, like a SBOM, to compare the actual software and the expected content of the software. And provenance. Provenance is describing what process was applied on the software. With them, we can verify the software is as expected or not. And the important thing is, this is very ideal big picture. Important thing is, in my opinion, the verification should be done on each process, and including the final process. Final process is execution. At the time to run the software, the user has to be able to verify the software is correct or not. And if the software is not correct, for example, the malicious software is introduced to that software, in that case, the action should be automatically applied. The action is, for example, to stop is one example, or to warn, just warn is one example. The final goal is to make the software correct automatically. For example, to apply the patch or something, right? This is a ideal status, I think. Oh, and I forgot to mention one thing. Well, the process and the content can be defined at the design phase or process, but one thing is dynamic, changed after the process of the software. That's a vulnerability. So the vulnerability should be accumulated and should be linked from some metadata like SBOM. That should be aggregated here somewhere, and SBOM should refer to them because it's dynamic. And of course, the verification at the final phase, examine whether the vulnerability is existing or not should be verified at the final stage. And of course, the action should be automatically applied. This is an ideal big picture of supply chain security. That's shared? OK. All right, so the next. Well, many things here. And so can we do that or not? Well, in this picture, for only one software, for example, the self-developed software, for that, it should be feasible. This case is describing the software is made by you. All components are made by you, made by me, and used by me. In that case, it's feasible because I can output the metadata, I can apply the process, and I can run that. In that case, I can verify everything because it's only one line, only for one software. But usually, we use multiple software. And nowadays, there is no software which has no dependency. So to do that, we have to use some distribution, including many softwares. In that case, it's nightmare. We have to verify 1,000 or over 10,000 software at the running phase. I don't think it's feasible. So, but what's the solution? The next page is the proposal from us. Distribution. Distribution is consolidated point of multiple softwares. The reason why we're using the Linux distribution is because I don't want to collect one software one by one, and I don't want to compile one by one, well, except for Gentoo guys. So that's the reason why to use the Linux distribution. It's a consolidated point, choking point. So Linux distributor, if distributor can do the job instead of the user, that's a very efficient. That can eliminate the duplicated job, which should be done on each user, done by each user. Okay. So what's the benefit of doing that by the Linux distribution is described here. So please, Takanori.
Okay. So this is, I think, is an ideal case of what Linux distribution can do. Here is 4 big parts. One is content consistency for SBOM. It means providing, of course, providing the SBOM with NTIA minimum requirements, and it's, of course, required. And also the format consistency for SBOM. Because currently many software, many vendors generating software and supplying such things to users. But that SBOM is not always in same schema or same format. But of course, for users, really applicable SBOM for users is more. It should be more consistency for in SBOM. So as far as it can be consolidated in Linux distribution, it can be more applicable for users. And also the open source collaboration, it means if we can consolidate such SBOM generation in Linux distribution, in open distribution, we can collaborate the information of the SBOM, each entity information, more accurate with collaborating with each other. So we can provide more correct information with SBOM. And also the providing trust is also important because kind of many people, many vendors supplying SBOM, but not with signing or not. Sometimes they are giving hashes, but for supplying the SBOM in supply chain, then end user need to check the SBOM is not crafted by someone, and the SBOM should be supplied from the original SBOM generator to the end users. So for doing that, providing trust is needed. And in our case, actually, in this case, I'm talking about Alma Linux and EM Linux we are contributing. In our case, we achieved these 2.5 about. Of course, we are providing SBOM for every packages, for every update, and also providing the SBOM in same schema, same format. And of course, it's open source and we can collaborate, but currently, not so much people is involved for brushing up the SBOM information, so we have to do more. And about the providing trust, because we want to do that, but I think currently there is not so much standard. Of course, there is Sigstore or many other signing technology, and also in total or such things, but not yet. But I think it's needed. So these 4 parts is a required role for Linux distribution, I think. But currently we are in middle. So we will achieve everything in these 4 parts. And also future directions and ideas. Not only the 4 parts, we want to establish the trust in SBOM. Of course, the Sigstore or in total, by using them, we can supply the trust in SBOM. Or SBOM quality improvement, like with collaborating with community, and also implementation the BEX and adapting the salsa. So the currently users recently users is more easier to get SBOM information from many softwares, but it's not reasonably applicable, I think. It's still hard to use. So Linux distribution's role is more supplying reasonable and applicable SBOM and secure supply chain to users. So we are continuously seeking the Linux distribution role in SBOM ecosystem. So this is our current idea and of the Linux distribution role. So if you have any idea or feedback, I want add the role or such things. So thank you.
Okay, the purpose to speak here is to hear your opinion, and we don't think it's a perfect idea. So let's share the idea, and please let me know your thought. Thanks so much.